All right, this stuff is just sort of the bonus extra features here about construction practice. All right, this is an interesting one. Use construction to determine which of the angles is not 60, or which are not 60. If you think about it, how many 60-degree angles, if there's any perfectly 60-degree angles in a triangle, you could pretty much either have 3 or 1. There's really no way to have 2. I guess, of course, you could have 0. But there's no way to have 2, because if you had 2, you'd have to have 3, because the angles have to have 180. So I think what I'm going to try to do is, let's just start with side AB, and let's just do the construction of an equilateral triangle and see what happens. See if it... Now this compass might be a little bit hard to get perfect. Because we're talking about, is it perfectly 60 or not? But if that goes through there, I'm halfway done. And then let's move this over here and really stab it right on there and try this. Is that really close? Yeah, that's awfully close. So then if I use I'm going to use my cheater straight edge because I want to try to make this really perfect. And I made this equilateral triangle AB whatever. I mean, that's pretty much an equilateral triangle right to that point. And by that point, I mean this point here. This completes the equilateral triangle. So if you look at these points on here, I look at the angles we have. I've made a perfectly 60-degree angle here from AB to that red line, and I made a 60-degree angle here from AB to this red line right here. And there's a perfectly 60-degree angle here to the red line. What angles of the original blue triangle are not 60? I'm guessing A was really 60, because it looks like that red line's right on there, so that's great. C, definitely not 60 because it goes, the blue angle's bigger. And if that one can't be 60, it looks like this one's actually just a little bit off, so that one's also not 60. So the only one that's 60 is actually just A. Okay, construct an isosceles triangle with vertex angle of 120. Okay, I have to construct a 120-degree angle. Well, what I was just doing here when I made these equilateral triangles, and I did one on an earlier page in the last video, you're making a perfectly 60-degree angle. And if I do that twice, I'll have 120. So let's start with, I'm going to need a lot of room here. So I'm going to start with some random segment. I'm going to build it into an equilateral triangle. And then we'll just do that sort of twice. And we'll have 120. Okay, so it's hard to get perfect on here. So make an equilateral triangle. That's part of it. Here's the rest of it. Great. Complete the equilateral triangle. Great. I didn't have to connect that last one because I know it starts at the segment, so I can just do that. So there's that looks pretty darn good, I think. Equilateral triangle. I could do one the other direction. I could have made that a little more efficient if I just drawn these in the first place. These perfect arcs from here and here. Now I'm going to have another equilateral triangle to there, and when I draw this one, I'll have two equilateral triangles backed up against each other. So guess what? I've got a 120-degree angle, folks. I got a 120-degree angle right here. Now the question wasn't just draw two equilateral triangles so that there's a 120-degree angle. It was, let's draw an isosceles triangle with a vertex angle of 120. Well, here's something. I already know that this side's equal to this side. I can complete this isosceles triangle if I just connect these dots. Watch what I do here. There's probably other ways to do this, but I just figured this will work. There we go. So if I label this triangle as A, B, C, triangle ABC is isosceles with a vertex angle of 120. Okay, construct a scalene triangle with angles 45, 60, and 75. Well, 60 I know how to do. I've just been doing that all day. 45 I found out how to do because I made you can make a 90-degree angle and bisect it. And then 75 I think is just going to happen because of the last angle of my triangle. So let's make, it doesn't really matter which one you do first. Let's do the 60 first, just for fun. So I make some random segment I'm going to use as part of my equilateral triangle. And let's make this, easier if I get this kind of on the line. What did I just do? If I make this kind of on a line, then I can, because with a real compass this is a little faster. Okay, assuming that's right on there. And the same thing from the other side. Okay, so that has to be, this is an equilateral triangle. In other words, I know I have, and wouldn't really have to draw this. I could just draw this here and I know I have a 60-degree angle, but I'll draw this like this so you can see this later and go, oh yeah, there's the equilateral triangle. That's how he knows he has 60. Then I got to basically make a 45-degree angle somewhere on one of these lines. I might as well just do it here. I'll make a 45. So in order to make a 45, I have to make a 90, of course. So let's make a big fat point here so I know we're talking about this is the center of my line. I need to make, or sorry, where I'm going to do the perpendicular. I'll make a line, and there's a zillion ways to do this. I'll make a line that kind of goes like, oh, I missed. Can I fix that? Just by dragging this down. Oh, I sort of can. Oh, I can move my line. I'm cheating. I can even rotate it a little bit until I get it just perfect. Oh, lovely. Okay, so I have a line that looks like that. And I want to make it so that, yeah, this is the Darth Vader bit. And this should, or the TIE Fighter, this should be the right size. Yeah, so if I just kept drawing this thing here, I'd have the two sides. Okay, it's a little bit off. The two sides of my TIE Fighter in those two places. Make this bigger than half. And actually, should I make that look like more like I usually do it? I'll make it look like I usually do it. I'll make this smaller so you can see it later. So I make a little arc there, and I make a little arc over here. There's my TIE Fighter. Stab there, a little bigger than half. How should I do this? Go above and below. How come I lost my pencil? Stab here, make a football. Whoops, ooh, don't want to change that size. Okay. Complete the football. Hopefully I didn't mess up that size. And so then when I make my straight line to the ends of that football, that's perpendicular. Well, I didn't want perpendicular. I wanted 45. Well, I've got a 90 here now. I just have to bisect that. Wow, there's a lot going on. I just have to bisect that, and I'll get 45. Oh, this reminds me another way I could have just done 120. See how I have 120 here now? I'm pointing with the compass pointer. And that last problem, I need to make 120. I could have just made a 60 and then extended the side. That makes 120. I didn't have to make another side, another triangle. Okay. So let's just make a random arc across this 90. It's a funny size. And then I do the bisector. So out in space now, I'm going to make a cross. This will probably be a good size. It's hard to keep track of all these arcs. Wow, look at all this stuff in here. There it is. So keep your eyes on that. That point I have to connect back to my vertex. So I know that oh, let me draw it in here. I know that A, B, C is a 45-degree angle. So I think I'm done. If I call this point D right here, I know that A, D, C has the angles I need. Triangle ADC answers my question. In that triangle, the angle at B, where am I getting ADC? Sorry, kids. Triangle, let's make it look good because this is gonna end up somewhere where you want to print it or something. So at triangle BDC, there we go. In that triangle, angle B is the 45. Angle C would be the 60. So that leaves angle D to have to be 75. Okay, and I think that's it. Okay, thanks for watching.